In our lesson today, we're going to learn about three-dimensional shapes, which are called solids, and later on we're going to look at cross-sections of solids. There are two different types of solids that we're going to look at today. The first are called prisms. A prism has two parallel polygonal bases that are congruent to each other. Okay, again, the things that we have to take away here is that it has two bases that are parallel to each other. Okay, two parallel bases. The other sides, which we call the lateral faces on a prism, are rectangles. And in order to name a shape, you name it by the shape of its base. Okay, so looking at our first prism here on the left, okay, I'm looking for the two sides that are parallel to each other, and these are going to be the bases. And that would be the top and the bottom faces here, which we are going to call pentagons because they have five sides. And because we name a prism based off of its base shape, this is going to be called a pentagonal prism. Okay, the word pentagon with AL at the end, and again, that's pronounced pentagonal. This is a pentagonal prism. In our second picture, again, the top and the bottom are parallel to each other, and in these cases, those are hexagons. Okay, and then the other faces are rectangles, which again makes it a prism. And since we name it off of its base shape, it's going to be called a hexagonal prism. Our third shape, okay, now on this one, we technically have three different sides that are parallel to each other, the top and the bottom, the right and the left sides, and the front and the back sides. Okay, regardless of how this is oriented, those shapes that are parallel to each other are all rectangles, and so this is going to be called a rectangular prism. Okay, so again, a prism has two parallel polygonal bases that are congruent to each other, and then the other sides are rectangles. And in order to name a prism, you will name it by the shape of its base. The other type of solid that we're going to work today is called a pyramid. A pyramid only has one polygonal base. The sides or the lateral faces on a pyramid are going to be triangles. Okay, and on a pyramid, there's a point that's opposite of the base, and this is called the apex. And just like with a prism, you name a pyramid based off of its base shape. So looking at this pyramid right here, okay, I can see it only has one base, and it's got an apex on the opposite of the base. And to name it, I'm going to look at the base shape, which has five sides, which is a pentagon. So this is going to be called a pentagonal pyramid. Okay, it has one base that's a pentagon. All of the other lateral faces are triangles. That is a pentagonal pyramid. In our middle picture here, we have, again, one base and the apex that's opposite of the base. The base in this case is called a rectangle, so this is going to be a rectangular pyramid. And then in our third picture, okay, again, we have an apex, we have the base shape. The base down here has one, two, three sides, which is a triangle. So this is going to be called a triangular pyramid. Okay, so the big difference between pyramids and prisms is that on a prism, all of the lateral faces are rectangles, but on a pyramid, they are triangles. And a prism has two parallel polygonal bases, while a pyramid only has one polygonal base. Now, each solid that we work with has three parts. It doesn't matter if it's a prism or a pyramid, they all have these same three parts. There are vertices, there are faces, and there are edges. Okay, the vertices are the corners or the points of the solid. The faces are the flat surfaces of the solid, so that can be the bases and then the lateral faces. And then the edges are the segments, the line segments, where two faces come together. Okay, so what we're going to do in the next section is try to determine how many vertices, faces, and edges these solids have. Again, the vertices are the corners or the points, the faces are the flat surfaces, and the edges are the line segments where the two faces meet. So again, what we're going to do for the following solids is tell what the name is, and then state how many vertices, faces, and edges there are. And then for the faces, we're going to explain what the base shapes are and what the lateral faces are. So if we take a look at the first picture, okay, we had this picture earlier. It has two pentagon bases and all of the other faces are rectangles. So this is again called a pentagonal prism. Okay, for the vertices, those are the corners or the points. So we're going to count. There's 1, 2, 3, 4, 5 on the bottom, 1, 2, 3, 4, 5 on the top. That's a total of 10 vertices. Okay, for the faces, the flat surfaces, we know that we have two that are pentagons. And then if we count all the way around, there's a total of 1, 2, 3, 4, 5 rectangles, which means that there's a total of 7 faces. And then for the edges, these are the line segments where the faces come together. We have 1, 2, 3, 4, 5 on the bottom, 1, 2, 3, 4, 5 on the top, and then 1, 2, 3, 4, 5 that connect the top and the bottom, which means there's a total of 15 edges. Okay, the bases, okay, so this goes along with the faces, these two segments right here. For the bases, we have 2 that are pentagons, and then the other 5 are rectangles because it is a prism. The middle shape, this is a rectangular prism. And for the vertices, just count the corners, 1, 2, 3, 4, 5, 6, 7, 8 total corners to 8 vertices. For the faces, okay, well, we've got the top, the bottom, the left, the right, the front, the back. That's a total of 6 faces. And for the edges, we have 4 on the bottom, 4 on the top, and then 4 that connect the bottom and the top, which makes a total of 12 edges. For the faces, okay, for the bases, we have 2 rectangles. And then for the lateral faces, there are 4 more rectangles. So there's a total of 6 rectangular faces on that rectangular prism. In our third picture, okay, this is called a triangular prism. Okay, the bases in this example are the triangles. Remember, the bases are parallel to each other. That's the front and the back triangles here. For the vertices, count the corners. We have 1, 2, 3 on the front, 1, 2, 3 on the back for a total of 6 vertices. For the faces, we know we've got the 2 triangles, and then we've got 1, 2, and the bottom third rectangle, which is a total of 5 faces. And then for the edges, we have 3 on the front triangle, 3 on the back triangle, and then 3 that connect the front and back triangles, which is a total of 9 edges. Okay, for the faces, all right, we had 2 bases that were triangles. And then for the other 3 faces, these were rectangles. All right. Underneath, we have 2 more solids. Again, we're going to find out what the name of the shape is, and then we're going to state how many vertices, how many faces, and how many edges there are, and then describe the faces. Okay, so notice down here, we're working with pyramids. Here on the left, the base shape is a rectangle. So this is going to be a rectangular pyramid. And for the vertices, again, count the points. 1, 2, 3, 4 on the bottom, plus the apex at the top makes a total of 5 vertices. For the faces, we know we have the 1 rectangle base, and then there's 1, 2, 3, 4 triangles, which is a total of 5 flat faces. And then for the edges, we have 1, 2, 3, 4 along the base, And then we have one from each corner that goes up to the apex, which gives a total of 8 edges. For the faces again, we have one base that's a rectangle. And then for the other lateral faces, there are 4 triangles. And then that leads to this picture right here. Again, it's a pyramid. Its base shape is a triangle. So this is a triangular pyramid. And for the vertices, count the corners. 1, 2, 3, plus the apex makes 4. For the flat faces, we have the one flat triangle on the bottom, and then 1, 2, and 3 more. So that's a total of 4 faces. And then for the edges, count the line segments. 1, 2, 3 along the base, and then 1, 2, 3 more that go up to the apex, which is a total of 6 edges. And now what we need, again, is a description of those faces. We have one base that's a triangle. And then the other 3 faces are also triangles, again, because we're working with a pyramid, and the lateral faces on a pyramid are a triangle. In the next part of the lesson, we're going to talk about cross-sections. A cross-section is the two-dimensional shape. Let's underline that. Okay, a cross-section is the two-dimensional shape you get when you slice a solid by a plane. And a plane is just a flat surface. You can kind of think of it like a knife. If you were cutting something with a knife, the knife would be the plane. Okay, you can cut through a shape vertically, horizontally, or at an angle. Okay, and we're first going to look at horizontal and vertical slices on a prism. In these first 2 examples, these are examples of horizontal slices because it's sliced horizontally through the middle, parallel to both of the bases. Okay, when you have a cut that's parallel to the bases, we're going to call that a horizontal cross section. And a horizontal cross section mimics the base of the prism. Okay, so this is a triangular prism. When we slice horizontally parallel to the 2 triangles, we get a triangle as the cross section. That's what this is right here. This is the triangular cross section. Same thing with our rectangular prism. If I slice horizontally parallel to the 2 top and bottom faces, I again get a rectangle that is a cross section. Now, if I were to slice vertically, okay, a vertical cross section is going to be perpendicular to the bases. All right, and in this case, notice the way that I slice it. Okay, I can slice it perpendicular through the top to the bottom, which now is parallel to the left and right sides. Or I can slice perpendicular through the top to the bottom, and this one is parallel to the front and the back faces. A vertical cross-section of a rectangular prism has dimensions that are the same as the faces parallel to the cross-section. Okay, so in this example, this cross-section is congruent to the left and the right faces. But this cross-section seen right here is going to be congruent to the front and the back faces because the slice was made parallel to the front and the back faces. Okay, it's a very similar story when we work with pyramids. Okay, with a pyramid, you can again slice vertically, which is going to be perpendicular to the base through the apex, or we can slice horizontally, which is going to be parallel to the base. So here's our initial diagram of our rectangular pyramid. This cross section right here, I have sliced parallel to the base, which is a horizontal cross section. When I slice horizontally parallel to the base, I again get a shape that's similar to the base. This was a rectangle, so this is also a rectangular cross section. If I slice perpendicular to the base through the apex, so again, I'm vertically going straight down through the apex to the base, notice this time that the cross section is going to be a triangle. Okay, so depending upon how you slice the pyramid, if you slice horizontally, you should get a rectangular slice because it's a rectangular pyramid. Or if you slice vertically through the apex, you're going to end up with a triangular cross section. So we're going to go a little more in depth now with the slices or the cross sections of a rectangular pyramid. If you make any horizontal slice of a rectangular pyramid, the resulting cross section or slice is going to be a rectangle. Okay, we mentioned earlier that if we slice horizontally, which means parallel to the base, that we're also going to get a rectangular base. The size of the rectangle depends upon the distance of the slice from the base. So you can see here on this pyramid, I've done 3 different slices. If I slice close to the base, I get a rectangle that's similar in size. It's a little smaller, but it's close to the same size as the base. If I cut up a little bit higher, so this maybe looks like I've gone halfway up, if I slice here, well, once again, I'm going to get a rectangle, but notice that the size of the rectangle has gotten smaller. If I slice close to the apex up here at the top, horizontally, okay, well, I again get a rectangle, but notice how much smaller this rectangle is compared to when we sliced close to the base. So the rectangle depends upon the size of the rectangle depends upon the distance that the slice is from the base. Okay, now if we make a vertical slice of a rectangular pyramid through the vertex, the resulting cross section or slice is going to be a triangle. The base of the triangle is equal in length to an edge of the rectangular base. The height of the triangle is equal to the height of the pyramid. So again, it depends on how you've sliced vertically, okay? In our first example, we've sliced vertically down through the apex, but it's going to be kind of parallel to this front and back edge. That's going to give us this triangle right here. Okay, but if I slice straight down through the apex to the base, this time parallel to the right and left sides, I'm going to get this triangle right here. Notice that these 2 triangles have different base lengths. This length is shorter than this length because this is shorter than this on my pyramid. All right. Also, notice that the triangles have the same height. The height here is the same as the height here because the pyramid is the same height. Now, a slice of a pyramid can also be vertical through to the base, but doesn't pass through the apex, like in each of these examples here. I'm still slicing straight down perpendicular to the base, but notice that my slice starts right there instead of the apex up here. When I slice straight down on this example, my cross section shown right here is going to be a triangle. Okay, this is a triangle cross section. And notice here, here's where my slice begins. Again, instead of at the apex, I'm slicing right straight down through the pyramid, not through the apex, okay, but it's still perpendicular to the base. And the cross section in this shape right here is going to be a trapezoid. So this is a trapezoid cross section. So if your vertical slice does not pass through the apex, you can get a shape other than a triangle. Okay, you can also get a trapezoid shaped cross section. So we're going to do a little practice with cross sections now. In example number 1, describe what the horizontal cross section of the given rectangular pyramid looks like. Note that the figure is not drawn to scale. Sketch and describe the cross section. Okay, so we can see here that we're slicing horizontally through the pyramid. It's parallel to the base right here. So this cross section is also going to be a rectangle. So I'm going to sketch a rectangle. Okay, and then we're going to give a description. First of all, we know that it is a rectangle. And I'm going to give a description of the dimensions. Now, I don't know the exact dimensions, but I know that the dimensions of the base, it was a 24 centimeter by 20 centimeter rectangle. Since we're going up on the pyramid here, this cross-section has to be smaller than that. Okay, so this is a rectangle with dimensions smaller than 24 centimeters by 20 centimeters. Okay, so if we think about this as a rectangle, this base right here has to be less than 24 centimeters, and this height right here has to be less than 20 centimeters, because the further you go away from the base, it's going to get smaller as you get up toward the apex there. So this has to be smaller than 24 centimeters by 20 centimeters. Okay, in our second example, the right rectangular prism in figure 5 has been sliced with a plane parallel to face LMON. If we look at the labels here, LMON is this right rectangular face right here. So we've sliced straight down through the top and the bottom, parallel to the right side, which means I'm also parallel to the left side, okay? Label the vertices of the rectangle defined by the slice as RSTU. So this rectangle right here is the cross section, and we're going to label it as RSTU. It doesn't matter which of these points you start at. All right, so I'll just start right here. Here's R, S, T, and I'll put U down there. And A asks, what are the dimensions of that slice? So I need to know how much this base part is right here from U to T. Well, that's going to be the same as this segment from L to N, which I can see is 10 centimeters. So I know it's going to be 10 centimeters by, now I need the height from U to R. Well, that's going to be the same as the height from L to M, which is the same as the height from N to O, which has been labeled as 11 centimeters. So it's a rectangle that is 10 centimeters by 11 centimeters. Part B says, based on what you know about right rectangular prisms, which faces must the slice be perpendicular to? Okay, so if we think about what happened here, okay, kind of think about this rectangular prism maybe as like a stick of butter. What we've done is cut straight down through that stick of butter. And so I want to know which faces did I slice perpendicular through? Okay, remember that perpendicular means forms a right angle. This cross section forms a right angle with the top face and the bottom face. I've sliced straight down through the top and the bottom at a right angle. Okay, so it's perpendicular to the top, which if I follow the letters is JPOM. And down to the bottom, which if I follow is KQNL. KQNL. Those are the two faces that are perpendicular to our cross section. All right, finally, in example number 3, we have another right rectangular prism that's been sliced with a plane that's perpendicular to face BCEH. So if I look at the labels here, BCEH is the bottom face, okay? The slice, the cross section is perpendicular to BCEH, which again, that is the bottom, okay? The resulting slice is a rectangular region with a height equal to the height of the prism. Label the vertices of the rectangle as W, X, Y, Z. So this is my cross section. I'm going to label it W, X, Y, Z. Okay. And now it asks in question A, to which other face is the slice perpendicular? Well, we said here it's perpendicular to BCEH, which is the bottom face. If it's perpendicular to the bottom face, then it has to be perpendicular to the top face as well, which is AGFD. AGFD. All right, our final question asks, what is the height of WXYZ? So I'm looking for the height here from W down to Z, or from Z up to W, and that's going to match the height from C to D, and that matches the height from E to F, which is labeled as 6 inches. So the height of this rectangle is going to be 6 inches.